Yeah, we're live. Excellent. What a day. As people are joining the live stream, I say hello and welcome and all of that fun stuff in between. I see there's only 5 people in so far. I just signed in, so who knows how long it'll take them to get themselves in as well. Today's Friday the 22nd. I wanted to remind you of a couple things before we continued with our midterm review. First, most importantly, your midterm is next week. Your midterm, because you are period 3B, your midterm will take place on Thursday the 28th. Please keep that in mind. You have the last day of midterms to kind of do that kind of thing. That's fantastic. So, I don't know, figure that out. But yeah, we will be reviewing. Now, on the day of midterms, supposedly, and the closer we get, the more likely it seems, supposedly I will see people in my classroom on the day of midterms. And assuming that I do, the midterm, of course, will be on Linkit, which is terrible. But you will be utilizing Linkit to get that midterm done. So please make sure you're coming in with charged Chromebooks on that particular day. For those of you who are virtual or who will be virtual on that day, I am going to be asking that you do join the Google Meet on that morning. I will put that reminder in Google Classroom because I'm not going to be doing a YouTube video of basically filming nothing for however long that is. But I will be asking people to be in that Google Meet on Thursday. Be able to knock that thing out. Friday of next week, and you should have gotten this schedule already, just so you know. This schedule, I think, was like sent home for everybody. But Friday of next week will be an A day, and Friday of next week will be the beginning of the 3rd marking period. So please make sure you're aware of that. So I will only see you on Thursday of next week for your midterm, and that's it. And then, yep, I'll see you the next week in February. February. Man, we are very close to being halfway done with this school year. That blows my mind. I don't even know. Anyway, in your Google Classroom from 2 days ago, I posted into the stream a PDF review of the midterm examination. We began working through that as best today. I want to go through as much as we possibly can. And of course, if you have any questions during the course of this review, you can ask in the chat. I will have I'm going to actually getting it open right now as I speak. I'm getting the chat open in my phone so that I can utilize it when we get there. If you haven't left a comment in the chat, please make sure that you do. That would be fantastic. See, there we are. See it right there. There's the inception. Watch, if I give it a moment, I'll hold my phone up. There it is, look. And then in the video, at a moment, there's the holding the phone up. It's so crazy. Anyway, I'm gonna walk over here. I'm gonna get my desk set up, and we're gonna get this review going. So let's see what we got here. Come on, you. There you are. So, last class, we left off on the first page of the review with number 4. Bring that thing over. There we go. And again, like I said, I can see the comments as I'm speaking. So if you do have a question while we're here, of course, I can answer that. Number 4. For the equation 4x squared minus 8x plus 3, it asks you to find the following. And this is stuff that we've done. This is stuff that we've worked on for a number of problems. But of course, it's not going to hurt to do it again. So that is what we're going to do. There we go. So starting with this problem, where's my little marker thing? There you are, little marker thing. I have a 4x squared minus 8x plus 3. Can't see that. You can see that, though. There we go. Much better. Now, they want us to find the discriminant. The discriminant is b squared minus 4ac. Now, as a reminder, the discriminant goes inside of the square root in the quadratic formula. It can tell you a number of things. If the value of the discriminant is a negative number, taking that square root will produce a non-real answer. If it's positive, then it will produce 2 real answers. And if it's 0, well, it will actually only produce 1 real answer. That's stuff we did in our notes from a long time ago. But let's figure this junk out. Be careful with how you type this stuff in. Notice how I put parentheses around my negative 8. Because when you square that, it should become positive. It should, and it does. Minus, boom. Right on the dot, the value of the discriminant is 16. Move that over there. There we go. You can see a little better. The value of the discriminant is 16. Now, what that means is we're going to get 2 real solutions. And in fact, that answers the next part. Number 4, part B. Describe the number and type of roots. 2 real solutions. Remember, if the discriminant is negative, you would have 2 complex solutions. If the discriminant was 0, you would have 1 real solution. And because we're getting the square root of 16, a positive number here, we're going to get 2 real solutions. Now they want you to find the vertex, which is like, okay, that's a little bit, of a left turn, but let's do it anyway. The vertex formula is negative b over 2a. All right. Negative b, again, be careful when you are doing negative b. Notice my use of parentheses. Divided by 2 times a. Oh, 8 divided by 8, which is just 1. Nice. Okay. I could deal with that. But they want the vertex. They want the full vertex. This is just the x value of the vertex. And since this is just the x value of the vertex, in order to find the y value of the vertex, I'm going to have to take that information and shove it back into the original equation. So I'm going to have to do a 4 times 1 squared minus 8 times 1 plus 3. If you did that correctly, order of operations, the whole deal, you really should be getting a negative 1. Which means that the full vertex is the ordered pair 1, negative 1. Now, I want you to notice something here. The next question is asking for you to find the solutions using the quadratic formula. I want you to notice something here. I'm going to read the quadratic formula. But as I'm reading it, I'm going to point to certain parts of what we just did. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac. The whole thing is being divided by 2 times a. Technically, we've just done all these different little parts of the quad formula. We just have to put it together. Correctly, mind you. The discriminant is b squared minus 4ac. It describes the number and type of solutions. The vertex, you're going to need negative b over 2a. Shove that sucker back in to get the y value. And now, I'm going to do a negative b plus or minus b squared minus 4ac. The whole thing over 2a. So, notice my use of parentheses, plus or minus the square root of 16. The whole thing is over 2 times a, which is 8. This really should be 8 plus or minus 4 over 8, which I'm going to have to simplify down in a moment. 8 plus 4 is 12. 12 over 8 becomes 3 over 2. 8 minus 4 becomes 4 over 8, which in reality is just 1/2. That's all this problem really wanted from you. Again, with a lot of these problems, they're basically, a lot of them are asking the same thing. It's just that they're asking it in slightly different ways. Okay. On the PDF of the review that you have, go to the second page. I'm at the top of the second page. Now, at the top of the second page, immediately we go into a completely different chapter. What is the remainder if you divide that equation by w plus 3? Oh, hold on. Divide, remainder. This sounds like a synthetic division problem. Because it is. Notice the numbers that I just put in to the chart right there. On the review, on the PDF review, it was a 3w cubed plus 7w squared minus 4w plus 3. They have to be in order by largest exponent to smallest. But now you're dividing by w plus 3. And I need to remind you of something. Let me look back at this problem real quick and let me zoom in on it. If you are dividing by w plus 3, w plus 3 is a possible factor. It's a possible factor. It may be a factor, it may not be a factor, but it's a possible factor. But on the outside of that synthetic bar, you are not putting factors. On the outside of that synthetic bar, you are testing zeros. And the 0 in question is not a 3. W plus 3, set it equal to 0 and solve, produces a -3. That is the proper setup for this problem. Remember, synthetic division is nothing more than repeated addition and multiplication, adding vertically and always multiplying by the number on the outside. So 3 multiply, add, multiply, add, multiply, add. Oh no, Mr. Markey, we didn't get a 0. Look, we didn't get a 0. We got a -3. Oh no, I guess I did it wrong. No, you did it correctly. The problem just wanted to know what the remainder was. It didn't say that it had to work. It didn't say that you were actually finding the x-intercepts. They just wanted to know what is the remainder. That number is always the remainder. All right. Next problem. Number 2. What are the x-intercepts of that equation? The equation in question is this. All right. Well, if I wanted to find the x-intercepts, I mean, there's a number of different things I could do. But the easiest, in my opinion, way to go about it, factor it. Use whatever method of factoring you prefer. I prefer Tucker method, where I go a times c to get -15. And I got to find 2 magic numbers that multiply to give you -15 and add up to the +2 in the middle. 5 and -3 should do the job. Now, those are not my answers. those are my magic numbers. Because it's a 1x squared, the t-chart would be split up 1x and 1x. My magic numbers would go in the bottom. Nothing would simplify, but I would produce an x plus 5 and an x minus 3. Again, those are not my answers. Those are my factors. In order to get the x-intercepts, the zeros of the function, you would have to set those equal to 0 and solve. And once you did, it would produce the two answers that you are looking for, -5 and +3. All right. Number 3 is an interesting thing. They want you to graph, but they want you to graph this weird-looking equation. Now, I'm not going to write it out exactly the way the paper says. Instead, I'm going to write it out like that. Move that up a bit. There we go. X minus 2, the whole thing, squared times x plus 6. You know, you could throw this into the graphing calculator and take a look. However, I know for a fact that the graphing calculator is not going to give you the best of images. A better method of going about this problem would be Desmos. I'm going to do both just to kind of prove a point here. But they want me to graph this thing. Now, what's interesting about graphing these things is the first thing they would prefer that you do is that you find all the x-intercepts. Factor it, find the x-intercepts. Technically, it's already factored. The x-intercepts should be +2 and -6. But the interesting thing about that +2 is that there's 2 of them. It's a repeated solution. And because it is a repeated solution, according to what we've learned, that implies to me that there's going to be some kind of a turning point at +2. Let's go to the calculator and see what happens. I'm going to have to reset this thing. Come on, you. Second plus sign 712. There we go. Clear. Wipes. Parentheses, x minus 2. Parentheses, x minus 2. Parentheses, x plus 6. Let's take a look. Graph. Again, I told you the graphing calculator doesn't really give the full story here. You see like one vertical, seemingly vertical line, and then a dip down, and then it goes back up. Oh, there's a lot of different things that you could get from this one problem. But a better way of going about it would be Desmos. Because with Desmos, you could easily alter the way the screen looks. So let's actually do that. Desmos. Graphing. F of x equals x minus 2. X minus 2. And x plus 6. There we go. But again, with Desmos, you could scroll back and actually see what's going on with this thing. Here we go. That was kind of nice. I mean, it looks terrible, but it looks kind of nice. See, with graphing these kinds of things, typically you're going to want to sketch them out. But you really need to recognize a few features. Number one, the degree on this polynomial is a third degree polynomial. The largest exponent should be like an x cubed, meaning the end behavior should be going in opposite directions. Furthermore, the leading coefficient is a positive number, which means those opposite directions should look like that. We already know what the x-intercepts are and the general idea as to what it looks like. So then the next part I would just need is just like a table of values, which you can easily get from the graphing calculator. Hitting second graph brings you to that table of values. But again, however, some of these numbers are so incredibly large. So what I would try to do if I was trying to graph this sucker, I'm going to draw something here. I'm going to try and be as accurate as possible. Okay. You can't see it yet. You can't see it yet. I'm going to go back to my screen in a moment. There it is. I don't feel like drawing that thing up top. See, what's going to end up happening on Linkit is that this is pretty much going to be like a multiple choice question where you would have to pick the image of the graph that looks the most accurate towards what the equation should be producing. Oh, it has a zeros at 2 and -6. Oh, it has a turning point directly at that +2. Oh, the end behavior looks like this. Yes, it is. The leading coefficient, now I'm not asking you guys to do this, but if you multiplied out all three of those, the leading term would be an x cubed, but more specifically, it would be 1x times 1x times 1x, which would give you a 1x cubed. So it'd be a positive leading coefficient. You don't actually have to multiply those out in order to figure it out. It's just recognizing the fact that the leading term would be an x cubed. And they're all 1x's. So it's a weird problem. Number 4 is one of those interesting things where it's like, wait a minute. They already did half the problem for me. Yeah, number 4 they did. On a problem like number 4, they want to know, what are the solutions to the following problem? And typically what you would do if you were faced with a problem like this, what you would do is you would factor it completely. Oh, wait a minute. It's already factored completely. Yeah, it is. It's kind of nice. And since it's factored completely, I can set each of those factors equal to 0 and then solve and then get my 3 answers. 0, 3, 1/2. All that was necessary. Recognizing the fact that it was already factored, take those factors, set them equal to 0 because the whole thing's equal to 0. Bada bing, bada bing, bada bing. I don't know how the phrase goes. Number 5. Again, just for reference, for those that are following along with us, the numbers that I'm referring to are on the PDF of the midterm review that I've posted into the Google Classroom stream. Number 5. Where will a graph of a parabola cross the x-axis if it has zeros at 4 and 2? This is a ridiculous question. There's a couple other questions that are just like as ridiculous as this one. But where will a graph of the parabola cross the x-axis if it has zeros at 4 and -2? What's another word for 0? X-intercept. Where will it cross the x-axis? At 4 and -2. I mean, you could write the ordered pairs if you wanted to. You could do like 4, 0 and -2, 0 if you wanted to. But like, it just seems so ridiculous to me. Why would they do that? Why? Number 6. What is the composition? Composition. Composition. If you remember, composition problems are the act of taking a function and shoving it inside of another function. F of x is equal to 5x plus 1. And g of x is equal to this thing. Now, as a side note, we're currently in the midst of chapter 6. This function is something that we're going to be dealing with exclusively in chapter 8. Keep that in mind. But they want you to perform f of g of x, meaning they want you to take the g of x function and put it inside of the f of x function. Well, what does the f of x function do? The f of x function performs 5 times the input plus 1. 5 times the input plus 1. Well, what is the input? The input is 1 over x minus 1. I mean, you could simplify it a little bit. There are multiple ways to simplify it. In fact, one of the methods that I'm going to be teaching you guys in chapter 8 would be to simplify something like this. But the best thing we can do for now is just this. That's the best thing we can do for now. I mean, if you wanted to, you could find a common denominator for the positive 1, x minus 1 over x minus 1, and then combine like terms on the numerators and keep the denominator the same. But again, that's something that we're going to be doing in chapter 8. Some of these questions are really silly. Just silly. Like number 7. Number 7's like, hey, f of x is equal to 10x squared. All right, that's cool. And they want to know, well, what's 4 times f of x? Wait a minute, you just literally want me to take 4 and multiply it by that equation? Yeah, I do. So it would be 4 times 10x squared, which would give you 40x squared. Yup. Just seems too silly sometimes. Number 8. Number 8 is asking for the inverse of that equation. They want the inverse, if I could spell inverse today, of y equals x squared minus 6. Now I'm going to remind you of a few definitions that we covered in regards to inverse. Number 1, if you were to graph a function and its inverse, they would look like reflections of one another across the line y equals x. If you were to find an ordered pair x comma y in the first function, every single ordered pair x comma y in the first function becomes y comma x in the second function, if they're inverses. And then finally, if you took the composition of the two functions, f of g of x, if they're inverses, it would produce nothing more than an x. It's kind of nice. One second. Oh, okay. Just reading something. So I got to find the inverse here. I'm marking none of those definitions helped us. Well, technically it does. Every single ordered pair, y comma x, or x comma y becomes y comma x. Literally switch x and y. If you want to find the inverse, then solve for y. Add 6. Square root both sides. Now, there's something actually interesting that comes into play here. And this is something we're going to focus a lot on in the second half of this new chapter. But if you introduce a square root to a problem, you must also include a plus or minus. Now, I'm going to show you this visually on the calculator in a moment. But yeah, that's what it's got to be. Let's take a look. I go here. Nope, go here. Clear. X squared minus 6 square root x plus 6 negative square root of x plus 6. Unfortunately, there's no way of me typing in plus or minus, so I'm going to have to do it with a plus and a minus with two separate equations. Graph. These two functions are inverses of one another. Prove it. Chapow. That diagonal shows the reflection that they are. Love it so much. Oh yeah. That would be the inverse. The next problem is talking about domain. The next problem wants to know what is the domain of this function right here. Well, domain is the list of all possible inputs. Domain is the list of all possible x values. Domain is how far left and right the graph stretches on the x-axis. What's a parabola? It's quadratic. Doesn't it stretch left and right forever? Yes, it does. So what does that mean? Well, for the domain, I'm going to write it as negative infinity to infinity. That's literally all I would have to write. Well, Mr. Markey, what if they asked us about the range? Oh, the range. The range is the list of all possible y values. The range is the list of all possible outputs. The range is how far up and down the graph goes. Well, this graph goes as far down as -4, and it goes up to infinity. So the range would be -4 to infinity. But you'd have to make sure that the -4 had a bracket around it because it actually touches the -4. Done. All right. Let's take a look at number 10. Number 10, how did the graph of y equals the square root of x minus 3 plus 5 shift from y equals the square root of x? Sounds like I should look at a graph. Yeah, it does. Let's clear this junk out. Now, clear you. There you go. Good. Oh, clear you. There you go. So let's look at the square root of x versus the square root of x minus 3. Now notice again that little arrow. You got to tab over to the right in order to get outside of that square root. Plus 5 on the outside. Now the first graph, the square root of x, is going to start at the origin. It's going to start at 0, 0. And they want to know, well, where did the second graph shift from? It shifted up and to the right. But how far up and how far right? If we go back to the equation, That plus 5 indicates the vertical shift. It shifted up 5 units. Clearly, it went to the right, but if you happen to remember, y equals a square root x minus h plus k, it's supposed to be an x minus h. So since it's an x minus 3, that h value was just positive 3, meaning it shifted to the right 3. Literally, you would say, oh, it shifted right 3 and up 5. Done. That's weird. Okay. Now, what I would like to do now, I want to skip around a little bit because I don't have that much time left. But I want to skip around a little bit and hit some of the problems that I feel we do need to hit before you leave here today. Because some of the following problems are things that you've done over and over again. And we've already covered those topics, whether it be on the open-ended's last class or on some of the previous problems we did today. So what I'm going to do is I am going to jump to the back page. Or technically it's page 3 for you guys. And I just want to hit upon a few different things here. Now, on the third page, is there a fourth page? I don't think there is. Nope, on the third page, number 17. Number 17 gives you the following image. Now, it's a little difficult to see precisely what is going on with all of that information right there. It's like, it's a little bit blurry. I wanted to make sure that I got the exact number at the top of that graph. So I actually did look it up in the original form. And the top number right there should be 4, 81.2. It's a little hard to see because it's a little blurry on my printout. I'm just hoping that on whatever you have, that it's a little easier to see. But now some of the questions. How long was the ball in the air? Well, its first x-intercept is at the origin, and it lands at positive 8. So it's been in the air 8, I guess, seconds. It doesn't really say. It doesn't really say the units there. So it's like, oh, it's been in the air 8 units. Sure. How high did the ball go? Now, any question like that, again, is in reference to the vertex. And I wrote out that vertex up there. But how high did it go? Well, it went 81.2 units. Again, I don't know. Feet, meters, yards, miles. I don't know. But then, at what times is the ball 60 feet in the air? Now, if you were figuring this out using the quad formula or what have you, you would take whatever equation you had and set it equal to 60 and then solve it from there. But since we have the visual, it's 60. Oh, it does say feet. So it's 60 feet in the air twice. Once on the way up and once on the way down. Again, I'm assuming seconds. 2 seconds and 6 seconds. You need to be able to carefully analyze any type of visual graph they give you. Speaking of which, number 18. Karen's marathon. Oh, Karen. They want to know between what 2 points is Karen traveling the fastest? There may be more than one right answer. Karen. In order to determine when Karen was moving the fastest or traveling the fastest, you need to find what line segments have the steepest slope, meaning the highest slope. A reminder as to slope. Slope is rise over run. Slope is change of y over change of x. There's actually 2 instances. One of them is right here. Because right there, when I'm filling in line segment A to B, she went up 6 and over 1 for a slope of 6. But now there's two other candidates for steepness here. I mean, it could be right here, this line segment. But I got to count this out now. It goes at like, it's at like 2.5. So it goes up like what, 3, 6, 9, and then over 1.5. Up 9 over 1.5. Up 9 over 1.5. If you divide those, you get 6. It works. Now, the last candidate is this last little one right here, but I wasn't too certain about it. So it's like, okay, where's the start? Starts out like 4.5, and then it goes up 3, 6, maybe it goes up 7.5, and then goes over 1.5. So it goes up 7.5, it goes up over 1.5. That slope is 5. Ooh, no thank you. Those two are the ones that I'm looking for. You need to be able to interpret these graphs correctly. Let's jump to number 21 because I would like to. I'd like to wrap up soon, so I'm going to hit a few more problems and then call it a day. But number 21, I haven't talked about what an axis of symmetry is, just because I find them kind of pointless. But technically, you already know how to calculate the line of symmetry. The way that you calculate it is with negative b over 2a. The line of symmetry is a vertical line that cuts your parabola directly in half. And that line of symmetry, that vertical line of symmetry, goes directly through the vertex. So if you calculated negative b over 2 times a, you get 3, which is a vertical line, x equals 3. That would be the line of symmetry. Whenever you hear line of symmetry, I want you to think vertex. But all you need is the x value. It's a silly question. Number 22. Number 22 wants you to basically just multiply out this polynomial, which we've done from like the beginning of the year. Just good practice. Be careful with how you're doing this when you are filling out this information. Multiplying it out like it was a lattice. And then combining like terms. Oh, you can't see it. Done and done. It's a silly question, but I like it. Let's talk about number 23. And then I think I'm going to wrap up with that today. I'm going to wrap up with number 23. Sketch a function that approaches positive infinity as x approaches positive infinity and has the zeros at the following points, or at the following numbers. Now, this one's a little strange because technically polynomials are supposed to give you both left and right end behavior. But this one only really gave you a right end behavior. Oh. -2, +1, +3. There you go. As it goes to the right, it approaches positive infinity. That's the right end behavior. It says as the function approaches positive infinity, as x approaches positive infinity. That's the right end behavior. Now, I got to tell you, there are I can think of like at least 4 different ways to draw this. But the easiest way is just that. That's the easiest way. See, the thing is, it has 3 zeros, but some of those zeros could be repeaters, but the problem didn't say. So since it didn't say, I'm not going to assume that. It gave you 3 zeros, which means at least it's a third-degree polynomial. And since it's a third-degree polynomial, or at least a third degree, could be a fifth degree, but if it's a third-degree polynomial, that means that the end behavior should go in opposite directions. Okay. Now, I'm going to wrap up here just with a few reminders. Obviously, we didn't do every problem on this review. If you have any questions, specific like, am I right when I tried this problem or something along those lines, then yes, by all means, email me. I would rather you send an email with just one question rather than not email me at all. Second, I had emailed a bunch of people with the blind CC on the email in regards to the Chapter 6 major, because I had a ton of people who did not do the Chapter 6 major. I have a problem with that. So if you didn't do the Chapter 6 major, you may have gotten an email from me. Please make sure you're jumping on top of that. The marking period comes to a close Thursday of next week. I'm trying to finalize grades as quickly as possible because I would like to get other things graded. So if you have any questions about that, please make sure, again, you are emailing me. I should start seeing some faces next week in real life rather than just in my mind. But I won't see this class until Thursday. But in lieu of that, I am going to sign off a little early. I wish you all a wonderful rest of your day. I will have to be here until 2 o'clock. But some of you are probably done with your day at 10:15. Have fun. Okay, bye-bye. Leave my classroom. Bye-bye, bye-bye, bye. Take your stuff with you. That's how I wave at people now. That's how I wave. It's like a crab hand. But yeah, I'm going to sign off. Bye-bye, bye-bye, bye-bye. Everyone, bye-bye, bye-bye, bye-bye. Email me, bye-bye.